for lesson 3's homework, we're going to work on our dividing segments proportionally. We'll do one graphing, we'll do one algebraically, and then we will do a midpoint. So point A is on segment XY such that XA to AY is 2 to 1. If X has the coordinates 2, 8, and Y has the coordinates 5, 2, determine and state the coordinates of A. So we'll do this one graphically. So first, 2, 8, there's A, 5, 2, there's B. I'm going to connect those two with a segment, and now we want to divide that piece. All right. So the key is here, they told us that the segment was divided in a ratio of 2 to 1. So if you remember, our fraction that we need is the first number over the two numbers added together. So 2 over 2 plus 1 is 3. Then we always want to find the actual slope of the original. So our slope is 1, 2, 3, 4, 5. So we're down 6 and over 3. So then what we want to do is we want to take each of those numbers and multiply them by our fraction. So if we do -6 times 2/3, we get a -4. And if we do 3 times 2/3, we get a 2. So now what we want to do is, instead of going down 6 over 3, we want to go down 4 and over 2. And there's going to be our point A. And sorry, actually, I labeled these points wrong in the beginning. They're supposed to be X and Y. So the coordinates then of point A is going to be 1, 2, 3, 4, 1, 2, 3, 4. So the coordinates of A then are 4, 4. All right. So again, just to recap, we draw our segment, we create our fraction based upon it's the first number over the sum. We find our slope, we multiply the slope by those fractions to get our new slope, and that will lead us to our point. Line RW has endpoint -4, 9 and 6, 24. P is on the segments of RW such that our ratio is 2 to 3. So we know our fraction we need is 2 to 5. Determine and state the coordinates of P. So if there's no graph, let's remember our formula. So this will be XP equals X1, which remember is always the point furthest to the left, which fortunately for us, they usually list as the first one. So XP equals X1 plus our ratio times X2 minus X1. And then we'll be doing the same exact thing for P, but every place we see a X, we're going to substitute out a Y. So our XP equals, our first X is -4, plus our ratio is 2/5, and then we are 6 minus -4. All right, so as we continue that down, -4 plus 2/5, 6 minus -4 gives us a 10. 2/5 of 10 is 4, and -4 plus 4 is 0. So the X part of our P is a 0. For our YP, our first Y is a 9, plus ratio is still 2/5, and then we are 24 minus 9. 9 plus 2/5, 24 minus 9 is 15. 2/5 of 15 is 6, and 9 plus 6 is 15. So then our coordinates for P are 0, 15. Algebraically determine the midpoint of segment QN if the coordinates of Q and N are 4, 8 and -6, 10 respectively. So remember, our midpoint is going to be our average of the X's and our average of our Y's. So here, XM is 1/2 4 plus -6. 4 plus -6 is -2. Half of that is -1. And then for our Y midpoint will be half of 8 plus -10. So when we do that, 8 plus -10 is -2, and half of that is -1. So then our midpoint is -1, comma -1. I just want to throw out a different way to do this. Midpoint is basically a 1-to-1 ratio. So if you wanted to use the same formula that we used in the previous problem with the XP and the YP, you can do that for midpoint. Just recognize that a midpoint is a 1-to-1 ratio, which is where you get your 1/2 fraction that you would use. And then in this case, you would just have to be careful because, again, you've always got to work from left to right. So the point that would be furthest to the left would be the -6, -10, and then the 4, 8 would have to be your x2 and your y2. All right, so if you wanted to use the same formula, it is doable. Just be careful on kind of the order that you use and then recognize the 1-to-1 ratio.